Hello and welcome to my video, lesson 3.2 on interpolating and extrapolating values. So interpolating just means inter, which means within, and understanding it basically. And extrapolating means without, or outside of what the data actually shows. So let's take a look at both of those. First here we're going to look at interpolating. So here we have a nice graph. This is a temperature versus time graph, and you can imagine that if you put a pot of water, it would start at room temperature about 20 degrees, and if you put on a stove, it would heat up and reach 100 degrees Celsius and boil at 100 degrees Celsius, so it would plateau and stop there. So, with that in mind, how long does it take for a temperature to reach 60 degrees Celsius? That's our question here on the right. So what we can do is we can pull out ourselves a ruler or eyeball it, depending if you are lazy or if you have a ruler. Those two things are both important. And so we went to 60 degrees on the left side. That's how we can see 60 degrees Celsius. It's shown on the left. And then what we do is we need to go down until we get to the time. And so let's just get rid of that ruler. So what we're going to notice is that over here is 90. Over here is 105. Whoops. Oh, I have to take off my wire to get the proper. Okay, 105. Looks kind of funky, but that's all right. So it's between 90 and 105, and so I'm going to say it's about 96. It's closer to the 90. So 96 seconds to get to 60 degrees. Okay, cool. What about the opposite? If we look at temperature first, instead of looking at, or seconds first, instead of looking at temperature first, we're going to look at seconds. So 135 seconds. So where is that? Well, it is 15 seconds after 120, so it's right here. And did I grab my green? Oh yeah, I did. Oh, whoops. Alright, so we're there. Now we can pull our line across. So wherever it touches our line of best fit. It's not perfect, but you know, you get the idea. So that's probably roughly 92 degrees Celsius. All right. So I hope that helps you understand interpolating. Interpolating means within the graph, just following the data that's on the graph. Now let's take a look at an example that is extrapolating data. So here we have a question with Google Sheets. The average soccer player runs about 1,500 meters during a soccer game. If a normal if a normal game lasts 90 minutes, how much has the player run by the 25-minute mark? That should say player. Let me just fix that. How much has the player run by the 25-minute mark? Okay, well, what you're going to have to do is find the 25-minute mark. So if you look at the bottom of our graph, we've got time, and we should actually have our graph showing the units. So time with seconds and distance in meters. It's always important to include units. Anyway, so we have time on the bottom, so 20. Oh, that's not seconds. Fool. Okay, sorry, it's not seconds, it's minutes, or meters. Okay. No, minutes. What am I talking about? Okay, so if we have 25 minutes at the bottom, that's halfway between 30 and 20. We go up till we get to this point, so we went straight up, just like we did with the ruler, and then we go straight across. And I'm going to say that's about 400 meters. So the player has run about 400 meters by the 25-minute mark. Now we have a second part to this question. How much does the player run if the game goes into 10-minute overtime? Soccer games often go into 1 or 2 minute overtime. 10 minutes is a little bit of a long stretch. So how much roughly has the player gone? So if you look here, normal game is 90 minutes. Tells us that in the question. So 10 minutes more is 100 minutes. So we go up, then we go across. And, roughly speaking, it's probably about 1,700 meters. That's not a very good color, is it? It's too bright. There you go. Alright, so I hope this video helps you understand how to interpolate and extrapolate values a little bit better. Good luck!